I'm Dr. Laszlo Pokorny. Welcome to this presentation on adaptive gamification mechanics, where we explore how personalized game elements can boost engagement and learning. Here we set the stage for a systematic literature review, highlighting the goal to synthesize evidence and map how adaptive mechanics are used in game-based learning across contexts. Let's summarize foundations, challenges, and practical implications. Gamification can increase engagement and learning outcomes. Adaptive approaches match mechanics to preferences, and real-time feedback supports retention. At the same time, scalability, standardized evaluation, and cross-disciplinary work remain gaps, so practice should prioritize dynamic user models, consistent assessment protocols, and designer-educator collaboration. Here we contrast fixed rewards with personalized motivation, explaining that traditional gamification often uses one-size-fits-all incentives that miss diverse learner needs. Adaptive gamification tailors mechanics dynamically to behavior and context, replacing static designs with context-sensitive rewards to increase participation and learning through personalized game elements and better situational fit. Here, we link psychological theory to adaptive systems, showing how building blocks like self-determination and flow interlock with real-time fit mechanisms. Think of it as a two-part puzzle. Core motivational needs form the foundation, while dynamic adjustments shift pieces to match skill and engagement, creating a responsive environment that keeps learners challenged and motivated. Let me highlight the main research challenges and gaps limiting adaptive gamification, including lack of standardized personalization frameworks, unclear trade-offs between granularity and scalability, limited longitudinal evidence, and dependence on ad hoc adjustments. These barriers restrict generalizability and computational efficiency, so future work must focus on robust validation and scalable algorithms. Here, we outline the paper purpose and roadmap. Consolidate fragmented knowledge on adaptive gamification, synthesize empirical effects on learning and engagement, describe methodology, and map trends and frameworks. The goal is to report findings, offer design recommendations, summarize domain deployments, and close with actionable conclusions and research priorities for practitioners and researchers. Our methodology includes the review protocol and data sources using a systematic Prisma search across core computer science and educational technology databases such as IEEE Explorer, ACM Digital Library, Web of Science, Scopus, ScienceDirect, Springer Link, and Google Scholar to capture both peer-reviewed and relevant gray literature. Described here are the search queries and analytical framework. Please note the focused search on original research combining terms like adaptive and gamification mechanics, excluding reviews and meta-analyses, and mapping 4 analytical dimensions: frameworks and models, learning impact, design strategies, and domain applications to organize evidence and compare approaches. Here we explain study selection criteria, including inclusion of empirical or theoretical peer-reviewed studies explicitly on adaptive gamification, with emphasis on post-2015 work but no strict time limit. Exclusions removed non-adaptive designs, insufficiently detailed methods, non-academic sources, and studies lacking full data needed for replication or evaluation. Let's look at the Prisma-like timeline for study selection. Initial searches identified records, followed by deduplication and title and abstract screening to remove irrelevant items, then full text review to evaluate eligibility, and a final inclusion step where studies meeting the criteria were retained for synthesis and analysis. Research trends reveal temporal and thematic shifts from 2010 to 2024, showing gradual maturation from foundational theoretical frameworks toward practical design, learning outcomes evaluation, and sporadic use of machine learning for adaptation. Recent years show growth in domain-specific applications, signaling a field moving from concept to applied research and deployment. Bridging theory and implementation is about tensions slowing progress. Frameworks are often theory-heavy without rigorous testing. Learning outcome studies are irregular. Design strategies lack systematic comparison, longitudinal evidence is scarce, and there is a need for a unified research agenda that connects theory, testing, and practice to accelerate cumulative progress. Here we survey adaptive gamification frameworks for education, distinguishing surface adaptations like badges and UI tweaks from core mechanic adaptation that dynamically adjusts tasks and difficulty through learner models. The emphasis is shifting from cosmetic features to task structures that better support learning while reducing instructor workload through automated personalization. Let's examine conceptual frameworks and taxonomy. We categorize approaches such as ontology-based student profiles, game mechanics abstractions, practical implementations, and theoretical architectures, explaining how each focus aligns with adaptation goals and offers distinct benefits from personalized experiences to ready-to-use deployment tools, helping practitioners choose suitable strategies. Here we show how adaptive gamification boosts learning. Personalized challenge and feedback sustain engagement and improve outcomes. Intelligent tutoring systems adjust challenge levels. Cognitive load is better managed during complex tasks, and dynamic tailoring keeps learners motivated without overwhelming them, supporting sustained motivation and deeper understanding. Let's look at science education examples where adaptive gamification impacts learning. Teachers report that tailored quests and rewards increase engagement and conceptual understanding, with automated personalization supporting progress tracking, while teacher-guided adaptations deepen concept mastery. The combined approach aligns tasks to student progress for improved outcomes. Here we weigh motivation benefits against limits, noting that personalization enhances intrinsic motivation by matching challenge and feedback, but requires robust learner modeling to avoid over-reliance on external rewards. Effective implementations balance psychological theory with pragmatic constraints to ensure models are accurate and reward designs support long-term well-being. Design strategy for combining adaptive learning and gamification calls for layering gamified rewards atop adaptive frameworks, adjusting game elements in real time based on performance, creating synergy with instructional adaptations, and designing for scalability while preserving pedagogical coherence, so gamified rewards enhance instruction without disruption. Profile-driven adaptation uses learner profiles to tailor gamification, social dynamics, and presentation. By capturing behavioral patterns and motivational factors, systems can personalize learning paths, tailor team challenges and recognition, and adjust gamified elements during sessions, enabling real-time interventions that increase engagement across cognitive and emotional dimensions. Let's examine design trade-offs and execution choices, comparing adaptive learning integration with profile-based personalization. Adaptive learning leverages established pedagogy for faster deployment, while profile systems enable deep customization but need more data and validation. The slide recommends balancing modification cadence, ensuring fairness, and piloting small with iterative fairness checks. Adaptive gamification for Generation Alpha highlights real-time challenge adjustments and personalized progress tracking tailored to digital native learners. The aim is to adapt frameworks to new demographics, evolve gamification in response to shifting educational demands, and design for fast feedback preferences so learning remains relevant and engaging for younger cohorts. Regarding opportunities and challenges, we summarize practical considerations. Adaptive mechanics integrated with LMS tools can personalize engagement while preserving instructional quality, but scaling personalization raises efficiency and modeling challenges. The recommended approach is to integrate learner models into LMS, prioritize robustness, and balance scale with pedagogy to protect learning goals. Here we restate that adaptive gamification drives better engagement by providing personalized adjustments that outperform static designs, while effectiveness depends on precision and timing of adaptation. Frequent, relevant personalization sustains progress and retention, so practitioners should prioritize reliable, timely interventions to maintain involvement and measurable learning gains. Linking motivation theory to adaptive computation explains how theories like self-determination and flow can be operationalized with ontologies and machine learning to create holistic personalized learning. Think of this as a bridge connecting psychological principles to algorithms that infer learner attributes and adapt mechanics to support both cognitive and emotional needs. Practical guidance offers actionable recommendations. Prioritize scalability by integrating with LMS platforms, balance algorithms with human oversight to protect pedagogy, develop standardized assessment frameworks, fund cross-disciplinary projects, ensure ethical safeguards around data and bias, support instructor training, and pilot and scale iteratively with collaborative oversight. Research limitations. Here we highlight constraints affecting validity, such as small-scale, short-term studies limiting generalizability, publication bias toward positive findings, wide methodological variation that hampers comparison, and insufficient evidence to establish robust causal links between adaptive gamification and outcomes. Calling for stronger study designs. Future research directions propose longitudinal studies assessing engagement and retention, expanding cultural and demographic diversity beyond Western samples, exploring hybrid adaptation that blends algorithms with human oversight, and creating open-source frameworks and shared data sets to enable replication, comparison, and cumulative progress across the field. Emerging technologies and ethics. Here, we identify opportunities like adaptive AI and VR/AR for immersive personalization while underscoring responsibilities to protect data privacy, mitigate algorithmic bias, and reduce dependence on extrinsic motivation. The takeaway is to integrate advanced tools with clear ethics policies, bias audits, and privacy-first design choices. Outlook and potential emphasizes the need to move from concept to empirically supported practice by addressing methodological challenges, expanding demographic diversity, enhancing interdisciplinary collaboration, and translating evidence into scalable education and training applications. The priority is rigorous research paired with inclusive, cross-field partnerships to realize impact. In conclusion, adaptive gamification outperforms static designs by personalizing game components to learner needs, blending psychological and computational methods to create innovative models, but practical gains require standardized measures, larger validations, and ethical use of emerging technologies. The next steps are to validate at scale, ensure inclusivity, and safeguard learner well-being as adoption grows.